Happy Sunday, everyone. I know you're probably not watching on a Sunday, but I'm recording on a Sunday. In fact, it's Super Bowl Sunday. So I got home and I turned on the TV and I'm like, I'm going to watch the game. But guess what? They have like 3.5 hours of a pregame show. So I'm like, I ain't watching 3.5 hours of that. I'm going to go do my work. So I'm going to record this video and then watch Tom Brady beat Patrick Mahomes for his 7th Super Bowl ring. Or is it 8th? I don't know. I forgot. Well, anyways, if I'm wrong on that, you can call me out. I hope I'm right. Here we go. This week is week 3 on, on exponents. And this week's goal is for us not to learn any new properties. You've learned them all. We're just going to put it all together. So we're going to do a whole bunch of examples over 4 slides like this of basically these properties. Ooh, look at that. Using more than one property at a time. Okay, so it's a more complex looking expression, and we're going to simplify them. And that is what your assignment is about this week. Okay, so let's go ahead and do this. The first examples have to do with the pesky zero exponent to make sure you guys understand how to deal with the zero exponent. This video is meant to be interactive as much as possible. So I'm going to do some, and then I'm going to say pause the video, and now you do some. Okay? I can't be there in person, so we can't really interact, but let's do our best. So pause, try it. All right, this first guy. What about if you have parentheses around an expression like 7x to the third, and that whole thing is the 0 power? What would the answer be there? Well, it would actually simply equal 1. That is because that 0 exponent, because there are parentheses here, applies to everything inside the parentheses. So in a sense, you can kind of distribute this 0 to both of these terms. So check it out. Here's how it works. You're going to have 7 to the 0. And then you're going to have this x to the third to the 0. This is actually the power of a power. And remember what happens when you have the power of a power. It's that third rule. You multiply the exponents. Well, so what is 3 times 0? Well, that would be 0. So actually you end up with basically 7 to the 0 times x to the 0, which is 1 times 1, which of course is 1. Now, you don't have to do all that work when you do that one. You can just simply say, if there are parentheses and then a 0 outside, everything inside the parentheses is just going to become 1. Okay? So now let's take a look at number 2. There are no parentheses here. So this is different. This is 7 times x to the 0. And 7 times x to the 0 is 7 times 1. So the answer for that one will be 7. Because without the parentheses, the exponent only applies to the closest term. It doesn't apply to everything inside. So do you see that difference right there? I wanted you to see how that parentheses makes a complete difference. With the parentheses, the 7 is also to the 0. Without the parentheses, the 7 is just a 7. All right, I'm going to pause now. I can't really pause myself. You have to pause me. And I want you to try number 3 and 4. Go ahead. So here's what you should have done. You should have realized that on number 3, because there are no parentheses, this 0 exponent only applies to the x term. So the answer here is 6 over y squared. Or technically, 6 times 1 over y squared, which is then 6 over y squared. You good? On the other hand, in here, that 0 applies to absolutely everything. So the answer is just going to be 1. Now, if you want to go through the process, you could say, okay, well, this 0 exponent applies to all 3 of these terms, the 2 on the top and the 1 on the bottom. So you end up getting 6 to the 0 times x to the 0 over y to the 0, which is 1 times 1 over 1, which is 1. You don't need to go through that, obviously. As soon as you see a 0 with the parentheses, you're like, ah, that's going to be 1. Okay. Let's do another different kind of examples. So you're going to see some like that in your assignment. So make sure you're ready for it. Ooh, and on your test. Because this week you guys have a quiz on all of these. So here we go. What about when you have some more complex looking expressions that involve multiplication? So again, I'm going to do a few together. I'm going to try the first 2 and I'll just do them with me, take notes, and then pause the video for number 3 and 4. All right, so here we go. We're multiplying. So if we're multiplying, you can kind of think of this as 3 times 6 times x to the 4th times x to the negative 2, okay? So multiplication is commutative. That means it doesn't matter which order you multiply in. You learned this back in 5th grade, that 3 times 2 times 4 is the same as 4 times 2 times 3. It doesn't matter what order you do it in. So that's why I'm doing this. This is 3 times x to the 4th times 6 times x to the negative 2. You can put the 3 and the 6 together and the x terms together also if you'd like. So that kind of makes it easier to look at it. So 3 times 6, you guys know that's 18. And now you have x to the fourth times x to the negative 2. What do I do with that? Well, since I have a common base, I can just use the product rule and simply add the exponents, see? So what is 4 plus negative 2? Well, that would be 2, and therefore your answer is 18x squared. There's another way you can look at this, and so I'm going to show you because I want to make sure this is clear. All right, let's also take this piece here, and I'm going to bring it down here. I'm going to do x to the fourth times x to the negative 2. You also learned that this x to the negative 2 can be rewritten as 1 over x squared. Remember that? So now what you end up with is on top you get x to the fourth, and on the bottom you get x squared. And if I expand it and then cross things out, I end up with x squared. So you see, the rules are consistent always. It doesn't matter which rules you use. Like here on the bottom in purple, I used the negative exponent rule to figure out what it meant. However, it was a little bit easier if I used the product rule. I can just get to my x squared a lot faster. Okay, let's try another one. All right, let's see. I have negative 5 times 2 times x squared times x times y to the negative 1. All right, I just kind of took all these terms and broke it apart and put them in a different order. Notice that these parentheses and this dot, they mean the same thing. I just wrote it in different ways. So here I'm going to get negative 10 because negative 5 times 2 is negative 10. X to the second times x to the first is going to give me x to the third. And then I'm going to have this y to the negative 1. But if I have a y to the negative 1, what can I do with that guy? Well, he can go on the bottom. So my final answer is negative 10 x to the third divided by y to the 1, or simply divided by y. So negative 10 x to the third divided by y. Okay, what I would like for you to try is to pause the video and try the next two. Okay. Actually, number 3 and 4 were a little bit tougher in a way because you actually have the power of a power. But we dealt with this last week, so let's see if you could figure it out. So this 3 applies to everything inside. So I'm going to get 2 to the third, which is 8 times x squared to the third. That's the power of a power. So again, we're going to multiply those exponents. So that's going to be x to the 6 times. Now this 2 applies to everybody in here. So that's going to be 25, not 10, times x squared. Okay, well, you could reorder these things, but you can do it in your head. 8 times 25, that gives you 200. And then x to the 6 times x to the second, that's going to be x to the 8th. If at any time you want to expand these things, you can do that. You can always expand things, make it a little bit easier for yourself. Like you could do this if you wanted to. You could say this is 2xx, that's what's inside, and it's being cubed, so I'm going to write it 3 times. And this is 5x, and it's being squared. And there, you can count the x's, see? There are 8 of them. And you can also see that 2 times 2 times 2 times 5 times 5 is going to be 200. You might need a calculator for that, but you could do it. Okay, let's see what about this one. So this next one is just going to be negative 3 times a times b to the second. And then here we have the power of a power, so we have to take care of him first. So 2 to the third is 8. You got to be careful you call that 8. Some students are like, 6. No, 2 to the third is 8. Then a squared to the third, well, that's a to the 6. And then b to the third will give you b to the third. So rearranging things, and you don't have to do this step, but you can. Just kind of rearrange the terms so you can put them close to each other and see them. So negative 3 times 8 is negative 24. A to the first times a to the 6 is a to the 7th. And those guys will give you b to the 5th. And so you're finally going to end up with negative 24, a to the 7th, b to the 5th. Okay? So make sure you took notes on these because you're going to have very similar questions in your assignment. And if you have these notes, you can see, okay, here are the patterns that I'm looking for. All right, we're going to pause right there for the first video, and then we're going to come back for a second video, and we're going to do a few more exercises together. This is good for you. Take notes and work with me. Pretend that this is like a real classroom. You got to go about it that way. I'll see you very soon.